In this film, we will explain using physics how it's easy to keep balance on your bike when it's moving.
How did you learn to ride a bike?
Well, my mum was holding the back of my bike. She promised me she wouldn't let go as I cycled, but then she let go immediately. I didn't even notice, so I carried on talking to her. I could ride.
Oh, what am I doing? When the bike is moving, it's easy to keep balance. When the bike stops, it's really hard not to fall off. Why is this?
We will use one science goon, one bike wheel with handles and added weights, one miniature roundabout, and one rope.
When the wheel is still, it is easy to tilt it using the handles, very much as you'd expect. Here is the force arrow diagram. When it spins, a new force is felt on your hands, but in the opposite direction, making it much harder to tilt.
The extra force helps to stabilise you when the bike is moving.
In other words, the extra forces when you spin it do this.
The angular momentum is defined by the axis of rotation. The angular momentum must be conserved in this direction. When the wheel is tilted, angular momentum is transferred to the person holding it so that the total angular momentum of the whole system stays the same.
Makes sense to me. Also, the wheel can do this, which looks magical.
The rotating wheel is an example of a gyroscope. Gyroscopes have lots of applications, from video game controllers to navigation. The Hubble Space Telescope orbiting the Earth uses gyroscopes a bit like our rotating science goon. The gyroscopes are powered by motors, and they allow it to point itself in different directions and steady its view. It uses 3 gyroscopes to be able to point in any direction. When the gyroscopes wear out, the useful life of the telescope will be over.
Hold on a minute, we didn't finish the cycling bit. The story of the moving bike is more complicated. Scientists have built bikes which cancel out angular momentum with extra wheels spinning in the opposite direction. Calculations have also been done using fancy maths. It turns out that the main reason you can balance is by making tiny movements with the handlebars to correct your position. The spinning wheel forces only account for about 5% of your stability.
Still, the bit of the wheel is really fun.